I'm here with Donna Guarrera. She's Assistant Director of SEM Division of Jeol Group in USA. Donna, you just said the use of correlative microscopy is possible now in a very different way. What does this actually mean?
Well, what I think of is, I guess, my pet peeve is we always use correlative microscopy. We've been using it for decades. Any scientist correlates visual data with chemical information. And what we mean by new is the workflow, or how we're allowing our scientists to make it easier for them to just get down to study the product. So I think the camera technology, optical microscope, and electron microscope technology have allowed us to integrate things better and faster.
What exactly makes your concept different to other concepts on the market?
Well, I think one of the things that we've done, and we're the first to do, was embed a color camera or digital camera in our SEMs, or Scanning Electron Microscopes. So some of them have been standard features for several years now. So basically you take a picture, a color image of your sample, and it displays on the electron microscope screen, and then from that color picture you can navigate to the area of interest, get your higher resolution imaging information and chemical information. Where we're expanding that is that's a fairly low resolution color image, and some of our new products now with the SEM Navigator give you a very much higher resolution image, a much larger field of view for people who have larger samples. The other area in this correlative workflow process is automated stitching of very large areas. So people want to look at things, the microstructure, but that microstructure, you have a very small field of view, micron scale. But if you stitch those together, we're talking several hundreds of them, and then to be able to automate that would be a very tedious task for any researcher to do, to sit there and click and click and click. But allowing that to set up something from a color image, do your high resolution imaging, walk away and come in the next day and have this beautiful high resolution montage map built for you, automatically.
Okay. What applications are you going to address with this system?
Well, I think three areas of scientific research have really kind of adopted this. One, in the biological imaging field, where they want to image very large areas like brain mapping. They want to understand where neural connections are. Energy research, oil shales, and understanding maybe where we're going to find easily natural resources that we can extract out of the ground. They've kind of adapted to this technology. And really the obvious one is semiconductor industry. They want to look at maybe a whole die and see it at very high resolution.